Alright, let's look at the example given in the textbook chapter 8 that I rewrote as a question. So the question is about profit maximizing or optimal pricing decision for joint product monopolies. Humphrey managers manufacture two different conference table legs, so multi-products, that are cut from the same piece of metal. They differ in their design but are jointly produced in equal quantities. Managers face the total cost function TC equal 100 plus Q plus 2Q squared. So again, it's one company, so it has one total cost function written in terms of Q. So Q here is the output, but then this question already says that the products are produced in equal quantity. So Q actually represents the amount of each output product A and B. So Q equal QA equal QB. So that's hidden equation in this example. The demand function or demand curve for the firm's two products are PA equal 200 minus QA, PB equal 150 minus 2QB. So each product has its own demand function or different markets, and Humphrey managers want to know how many units of each leg, A and B, they should produce to maximize profit. Okay, let's solve optimal price for both products and the quantities. So I copy the total cost here and the demand function, which is written in inverse demand form for each product, right? So for given total cost function, I can generate marginal cost by applying delta operation or derivative with respect to Q. So constant becomes 0 and Q, 1 multiply Q become 1, right? And plus, of course, you maintain the plus sign, and 2Q squared become 2 multiply 2Q, so it became 4Q. So marginal cost function is written as 1 plus 4Q that you can generate from total cost function. And when you have inverse demand function form, marginal revenue, especially for linear demand function, marginal revenue can be written as same constant and multiply 2 in front of Q. So twice steep, so 2QA, so that's marginal revenue for product A, and marginal revenue for product B will be again 150 minus multiply 2, so it became 4QB, right? So we can say total or sum of the marginal revenue from product A and B production will be marginal revenue equal this plus this. So 200 minus 2QA plus 150 minus 4QB, I have 350 minus 6Q, and I can write it Q because they're single production, so this output Q indicate the level of output QA and level of output QB, as A and B are produced from single production at same amount, fixed proportion. So I have this marginal revenue for both products, which we call total marginal revenue for joint products, which is simply by summing up these two expressions. Now I can apply the fundamental profit maximizing principle by equating this with marginal cost, which is 1 plus 4Q. So by equating these two expressions, I know 349 equal 10Q. So profit maximizing optimal output Q will be 34.9, which is also the optimal amount for output A, also output B. So I found it. And then note that always check when QA, QB equal 34.9, marginal revenue for profit maximizing should be never become 0. So when you plug this number to marginal revenue for product A and marginal revenue for product B, so here MRA 200 minus 2 30.9 34.9, this will be greater than 0. And for marginal revenue for product B, 150 minus 4 30.9, this is also greater than 0. So producing 34.9 output for product A and B, they are both fine as marginal revenue. Producing additional unit does not decrease total revenue. So that's fine. So these are confirming the solution QA, QB are both equal to 34.9. Then now we can find optimal price PA, PB. Again, be careful not to plug in back to marginal revenue curve. This and this, to calculate price, you always plug in back to demand function. So plug 34.9 to here and here, right? So PA, price for product A is 200 minus 34.9, which give you 165, which give you, let me write it here, 165.1, and for price B will be 150 minus 2 multiply 34.9, so that is equal to $80.2, $80.02. So 20 cents. So that is the answer. And that's the case 1 where marginal revenue at the optimal quantity is greater than or equal to 0 and fixed proportion is maintained at optimal decision. Thanks for watching.